Okay, welcome to the workshop videos for additional trigonometric functions. Okay, so there's a couple of things I want to draw out for these, which are related to the white sheet and the 12 weeks of encouragement that you have had concerning how to do exact values trig. There'll be a few other things involved in this as well, but essentially that's where we're headed. So consider the following trig functions. The angles measured in radians. These are periodic functions. So periodic functions repeat at regular intervals, and those things are called periods. Now that's going to be a point that you're going to need to get used to here. Periods are very important in the calculations that we do. So how do we see that period? If I shift the sine wave up to some value, right, and it's just a standard waveform, it will cycle like this. Okay, it'll cycle pretty much to 1 plus 1 would be 2, and down here it's 0. So what we get is a repeat cycle. So it can be starting at 0, or it can be we can pick any point to determine what the cyclic or period is, the cyclic interval. So we have our f of x for each of these. This is a sine wave, obviously. And we have our f of x plus some period p. So between those two, some period p. And we generally suggest that's positive. And if it's important for you to recognise that. Okay? So we've got x plus p. And so there is our periodic function. So for any domain. So what we can do is have a look at those for each of our parts. Now we're not going to get away from diminishing triangles. A diminishing triangle still exists. So we look at our unit circle. And our unit circle is all important in what we do in trig. So being able to set those up, understanding that pi and 2 pi exist, and then being able to consider the angle on an axis, or on an axis, what is y and x, what's happening with y and x, and then our diminishing triangles. So I'll leave that for the moment, but essentially that's the skill set that I've been leading with you to do for 12 weeks. So we need to know a little bit more about our sine waves, so let's have a look at that. Alright, so in this particular example we've got a cos. It's got a period that's related to 2 pi. That's the usual convention that we have. And so what we look for is our cos wave, which starts at the top here and cycles to 2 pi. So half of 2 pi is pi. If you do a symmetric point there, you'll see that that's pi. And then you can halve them again. Okay, so on our waveform here, what we'll get is, I might just make that a little bit smaller and a little bit thinner. And what you'll get is what we're used to. So we start off with 0. That's this corresponding point here. Okay, 0. And then we've got pi. And what's in this quadrant here? Pi on 2. So this is pi on 2 here. And so pi on 2 looks to work. So this is our first quadrant. So everything that's happening in our first quadrant here is happening here. Now that's not obvious at all, so it takes a little while for you to get used to it. So don't be too concerned about that. Now in our unit circle, when we have a hypotenuse of 1, then we can call this exact values. Okay, because whatever we get for our variations here will usually be in increments of predefined regular increments. Okay. However, if it's not an exact value, it's not the end of the world. Okay, because we can work out the angle. So if it's given in regular angles, regular divisions around, then what we can do is we can pretty much work out what the angles are going to be simply by counting as multiples of this base angle, which is fairly straightforward. And so we have some formal language that I've kind of not used up to this point. So we've got some x-intercepts. So the x-intercepts occur where cos of 0 is equal to, where the cos of x is equal to 0. Okay, where cos of x is equal to 0. So the cos of x equal to 0. And so the cos of x is equal to 0. And in our case, it's pi on 2. Now, if we look at this one, cos means what by association? Now, I've taught you this. Association is cos. Now, because we're using the variable x here, I'm going to change these sheets in the future. We associate this with cos. Cos we associate with x. Having the cos of x is no different to having the cos of y, or the cos of theta, or the cos of r, or the cos of any other variable. It's irrelevant. That's irrelevant. The cos represents x. So if cos is looking here, what's cos at pi? What's cos at, in other words, what's the x value at pi? It's minus 1. And there it is. Minus 1. Okay. What's the value at pi on 2? The x value of this diminishing triangle is, so this length here is x, this height here is y, and as this triangle moves up and becomes part of this axis, the x part disappears. It's become 0. Okay, so at pi on 2, it's become 0. So we can say that this is occurring for x is equal to pi on 2. Now also we know that it happens at pi later. So we can formalise that language by saying, well, yes, it happens at pi on 2, but it also happens when we add pi and we add some count of pi. So in the first instance, we might use k. Now k is an integer, and that integer will be a whole number. Okay, so k will be equal to 0, 1, 2, 3, all the integers, depending on how many times we want to cycle around, and we'll pick up the x-intercepts as multiples. So you've got to get used to saying in terms of, oh, is it pi on 2? Or is it this one over here, pi on 2 plus pi? So that would be 1, wouldn't it? Pi on 2. And if we make them do our little stuff that we do with adding fractions, there's our 1 in disguise to get the same family. Okay, so that's the same family. And we get 2 pi plus pi over 2. So now we can do the sum. 2 apples plus an apple is 3 apples. Textbook would write it like this. I have asked you to write that as 3 lots of pi on 2, because it's a much easier way to count. Pick up the angle. So there's our pi on 2. 1 lot, 2 lots, 3 lots. So we can count around for 3 lots. So this is the other place. This is the other place where the x is diminished to 0. There it is there. So they're all related. The maths should all be the same meaning there's no new tricks in this. I think that happens a lot from school where people get confused. But likewise, where is it 1? Well, it's 1 at 0 and counts of pi, so 0 and 2 pi. But now it's not going to be an addition of pi. It's going to be where cos x is 1. So it's going to be counts of 2 pi. So we'll just say 2 pi k. Now, does that work for 0? Well, if k is 0, 2 pi times 0 is 0, tick. If k is 1, 2 pi times, there you go. So it picks up both maxes. Okay, it's the same for the negative 1. What will happen with the negative 1? Well, negative 1's occurring at pi, so that's over here. So negative 1's occurring at pi, and so we can count pi, but we would need to go a whole circle because there's only one negative in this cycle, so a whole circle, 1. So we can put plus 2 pi, so it'll occur when it's pi, and then we can go a whole cycle. So in the first, and we've got to get used to this nomenclature because it'll be used in Math 1. When you do a subject called complex numbers, a topic called complex numbers, this whole count thing comes back into play. So it's better that we pick it up now. All right. Now, the other thing I wanted to point out to you is that in terms of angles, we can also consider the negatives. So that's positive theta, isn't it? But for negatives, we can start off with a 0 and we can go negative theta. And the same things occur. And this will be 2 pi, but it'll be negative 2 pi. And the important thing about that is that if we take a look at what happens at pi from a positive point of view and a negative point of view, we can see that cos pi, okay, cos pi will be, let's just put the pen colour back, cos pi is asking what's the value of x at pi. What's the value of x at pi? Okay, so if we go over here, x is this big long one on a diminished triangle, isn't it? So cos pi is equal to minus 1. Now, what happens? That's this angle. That's when we go in the positive theta, positive x direction. So then we go to what happens to the cos of minus pi? And where's that sitting, you ask? Over here, in this point. So all of these things can be repeated. This can be as minus pi on 2, and so they'll have equivalence, equals minus 3 lots of pi on 2. They are equivalents. They are equivalents. And if you put them into your calculator, you will get the same. You will get the same thing. Okay. So let's we'll have a look at that also. So either way, no matter which way you do it, it'll work out. So for example, we know from our triangle here that the exact value is triangle, and we know the values because we've been doing our white sheet. We know the short side is a half, and we know the long side is √3 on 2. So we know that cos 30 degrees has the bigger denominator. So we know that that's cos pi on 6. Okay, so it's asking for the length at pi on 6, which is this length here, which is equal to √3 on 2. That's our cos or x value at that point. Further to that, if I now go and have a look at the examples of the negative, so there's 1, there's my negative count, 30, 60, 90. So look at this, it's matching up. I'm counting all of these marks that I marked earlier are all getting marked in red. So what I've got to do is count around. You ready? Count with me. -1, -2, -3, -4, -5, -6, -7, -8, -11. So cos -11 minus 11 lots of pi on 6. So that's our count. Should also be equal to √3 on 2. So let's have a look at that. So we'll do the pi one first, and we'll do the pi on 6 one. So let's have a look at our calculator. Let's see what the decimal looks like. So if I do √3 on 2, take the square root of 3 and divide it by 2, I get this number 0.866. For those of you doing engineering, it'll become very common very quickly. So I got 0.866. I'll just clear that away. So I know that that's going to be our √3 on 2. Okay. Now, if I take cos pi on 6, I'm going to take pi divided by 6 and take the cos of this. Oops, I'm in degrees. Radians. Thank you, Jason. This thing. Oh, didn't put it into radians. So it didn't work. Pi divided by 6 equals. Now we're going to take the cos of this. And we hit cos. Aha. 0.866. That's √3 on 2. So tick. Tick for this one. Okay, very good. Now let's do the minus. Well, that'll be a bit trickier one, I think. So we'll have to do minus 11 times pi. So we'll do 11 times pi is equal to, and divide all of that by 6. It doesn't matter what you can do one or the other. That's equal to minus 5.6. Now let's go and have a look at trigonometric cos. Ta-da! 0.866. It's the same. So we can say this is the same one. Very good. How good is that? This is really now what we're showing is the equivalence of positive and negative. You're going to need this with your exact values trig and your diminishing triangles more than any other topic in Maths 1. Okay, all of the other things that I've taught you have been important, and I've emphasised the chain rule, I've emphasised the U substitution integration, the 6 things, and this is part of those 6 things. All right? Now, we could go along here and make up a table to describe this, but I'm not a big fan of tables. I'd much prefer that you worked out what these things look like by using your diminishing triangles diagram. Okay, so if I take along theta or x, this has been given as x, which I think is anomalous, but there we go. So if we do count around the circle, we can do 0, so we do pi on 2, that's the 90-degree axis. Then we can do pi, and we can do 3 lots of pi. So we're just looking at the axis. 3 lots of pi on 2. And then we can go for 2 pi, and then we can see what the value is going to be. So it's much easier to ask the question, what's x doing at 0? X is 1. Okay, that's interesting. X is 1. What's x doing at 90 degrees? Well, we already worked that out as 0. There it is. X is 0. You can do the table thing, but rely on your diagram. Learn to use your diagram. There's x minus 1. 3 lots of pi on 2. X is 0 again. Cos. Remember our association? I know it says cos x, but it could be cos theta. So we know that's 0 again. Okay. And then 2 pi. What do we got for 2 pi? It's 1. It comes back as 1. Now for the negative angles, it's no different. You just count around if you need to. Minus theta. Okay. It's going to be the same. X at minus theta is that one. It's 1. So we just put a 1 in. Easy. Pi on 2, negative pi on 2. Negative pi on 2 will be, oh, there it is, 0. It's the same. Things don't change. Simply because you put the negatives in. Negative pi minus 1, there it is. Negative pi is minus 1. So all of these things, I'm trying to get you in your training of this subject to become a bit more autonomous and use recognition. Okay, it's a big deal and you need it. Recognition. Okay, now I'm not going to go through this length of detail for all of these. We've just done the cos waveform, but we'll work through some of these ideas with the code because this is new information, isn't it? Putting up this way of information. And I'll be back soon, and we'll do that in the new video. Part 2. Back soon.